YouTube famous. Unit 2, Day 5. Polynomial division. Polynomial division. And I guess we're going to do three things, and then we'll do some applications. So we're going to do, like, I don't know what to call it, third grade division, number division. Maybe it's fourth grade. Somewhere in there when you actually do division by hand. We'll do a little bit of that because that process is exactly the same when we get to long division with variables, numbers, letters. But it's the same process, and so that's why we'll take a couple minutes to do a third grade problem or a fourth grade problem, because it's probably been a while since you actually long divided by hand. And then we'll do synthetic division. So those two have the same process. Synthetic has a different process, but it has the same purpose as long division. So you get the same, you would do it in the same situations and it would tell you the same thing. So maybe that'll help make sense of where we're headed. So let's first do just old school elementary school division. I don't even know what to call it. It's third grade, fourth grade. Let's do 3,793 divided by 4. Now, in theory, everybody knows how to do this, but really, when was the last time you actually did a long division problem like this? Middle school? I don't know. You usually have a calculator when you're here. So let's see. 4 goes into 3. No, 4 does not go into 3. 4 goes into 37. How many times does 4 go into 37? 9 times. Right? You want to get it as big as you can. And then the next few steps, we're going to slow way down. I hope your brain takes over and you know the process, but we're going to slow it down because when we get to long division, it's the same process but with letters. So what do I do with the 9 now?
You subtract it. You multiply 9 and 4.
Multiply the 9 and the 4. 9 times 4 is 36. And then, Ben, what do we do?
Subtract it.
Now we subtract. 7 minus 6 is 1. Then what? Bring down the 9. Remember, it's important to be neat and keep your columns nice and neat on this. So 4 now goes into 19 4 times. And 4 times 4 is 16. And then we change the sign. 3, and then bring down the 3. And then 4 goes into 33 8 times. 8 times 4 is 32. Change the sign. We get a 1. And now there's 3 different things you can do. Do you remember what those 3 things are? What's one of them? Okay, so you can go remainder 1, because that's what's left over. That's the easiest thing to do. That was the first thing you did when you did division. You probably don't remember back in 4th grade or whenever. You just said, oh, there's 1 left over, so remainder 1, and you just stopped there and didn't think anything of it. Later, what else could you do?
You just put a point 0.
Yep, you could put a 0.000 and then keep the problem going for as long as it takes, or until you realize it repeats. That we won't do that today. We will do the remainder thing. What else could you do? This was the last thing you did. So you're naming them in order. The remainder, the decimal stuff, and then when you got really fancy, what could you do with that 1? Make it a fraction. And what would the 1 be over? The 4. Okay, those are the 2 methods we'll use today. So the good news is, I guess you don't have to keep adding zeros and bringing down and none of that. You'll either stop and say remainder 1, or you'll stop and say 1 over what we divided by. Okay, now that ends our trip down memory lane, but do you remember how to long divide with numbers now? Okay, good. Because now we're going to use the same process and do long division with polynomials. So harder? Yes, absolutely, but the process is the same. So I'm hoping you make that connection, but we'll see. 2x cubed plus 8x squared minus 3x minus 4 over x squared plus 2x minus 1. Okay, yeah. Maybe this is obvious, maybe not. But if the top degree is greater than or equal to the bottom degree, we can divide. So like there'd sort of be no point if it was the other way around. The top's got to be bigger than the bottom. That's the same for numbers as well, right? If you had 3 divided by 4, you'd be like, well, I can't really divide that. It's got to be the other way around. It's the same thing here. The top degree has got to be bigger than or equal to the bottom degree. If it is, we'll divide. So we'll set it up just like we did the elementary school problem. And kind of like we did earlier, like the lead terms are the important terms. So I can ignore a lot of this stuff, at least initially. What times x squared would get me to 2x cubed? 2x. I need a 2 and I need another x. So I'm going to start with 2x. Some people start over here at the left. I like to keep things lined up. So I'm going to put the 2x over the 3x. That's going to be my x column. My power columns will all be the same. Okay, so we know 2x is close. That'll make the 2x cubed match. What do we do next? What did we do next when we were doing elementary school division? Multiply them together. So we'll do 2x times our divisor, if we want to use the fancy words. So 2x cubed plus 4x squared minus 2x. Multiply it back. Again, if we're careful, all the squareds and cubes should line up for us. What did we do next when we were in 3rd grade or 4th grade? What's that?
All of them, right?
You subtract all of them, and so one way we say that here is we change their signs. So we got to change their signs. I can still hear my Algebra 2 teacher saying, draw that line and change those signs. If the sing-songy rhyme thing works for you, as it did for me 30 years ago, draw the line, change the signs, because you're subtracting. The lead term should always go away because we forced that to happen, right? We picked the 2x to make that work. After that, who knows? Let's see. 8x squared minus 4x squared. Negative 3x plus 2x is negative x. Right, what did we do next when we were in 4th grade? Bring down the negative 4. So now I'm looking at how many times does x squared go into 4x squared? Or what times x squared would get me to 4x squared? A 4. And we'll multiply it back. So 4x squared plus 8x minus 4. Draw the line, change the signs, or subtract. Again, the lead term goes away because we forced that to happen. If that doesn't happen, then something went wrong somewhere. Negative 9x plus 0. Okay, well, a couple things that should indicate that we're done. I don't have any more room up here to put anything. And what times x squared would get me to 9x? That feels backwards. So I think we're done. We can say the remainder is 9x. But I think our better answer would be to use the fraction thing. So there's our answer. And this could be one of those things. It's like, well, why do we do this? And this answer may not be satisfactory to you, but in calculus, there are things we can do with this answer that we are not able to do with this original. So when we get to calculus, there's a whole section where we got to do this, and then we got to do something else. So that's a really long problem because what we're doing today is like step 1 of 5. But it's got to be step 1. So today we work on just step 1, and that's the only step we'll do. Let's try another one. Four x to the fourth plus 2x squared minus x plus 1, all divided by x squared minus 2x plus 3.
What's the problem?
Oh, maybe I should put it where you can see it. 4x to the fourth plus 2x squared minus x plus 1, all over x squared minus 2x plus 3. This one has a little bit of a trick in it. Do y'all remember if you did this in Algebra 2? Most?
No, we did it.
Okay, some yes, some no.
We did
I'll
this.
have to see it.
I don't remember this at all.
It might have been an honors level thing. So we're going to do the top divided by the bottom, but there's something a little bit wacky about this numerator, especially when I think about keeping all my columns nice and neat by powers. I want all my powers to be present. I need to put in a 0 for the x cubed. So it feels a little bit weird maybe to write 0x cubed, but I need all my powers to be there so that this thing stays nice and neat. Okay, now it's the same as the last one. So that extra is missing 0 in there. All right, so what times x squared gets me 4x to the fourth? 4x squared, and so I'm going to put it over the x squared term. I think most books and most teachers put it somewhere else, but I like keeping all my powers lined up. All right, multiply it back. 4x to the fourth minus 8x cubed plus 12x squared. What do we do next? Subtract and or change the signs, however you want to say that. I think that's easy to remember because you know this lead term has to go away, and it's only going to go away if you change its sign. And now I'm glad that we remembered to put the 0x cubed in there. subtraction, and bring down the rest of it. And now we basically start the problem over again. So what times x squared gets me 8x cubed? 8x. Why don't you see if you can finish it from there? So definitely an 8x. So multiply it back, do the subtraction. Looks like you'll have to do it one more time after that. See if you can finish that problem. All right. Does that look good? Oh, it's frozen. Let me unfreeze it, and then you can see. Does that look good?
Yes.
Okay, so the steps are the same as 4th grade, but obviously it's a little trickier with all the x's floating around there. And again, please be neat. Most of you are neat. Most of you know that being neat helps you, especially the more complicated math you're doing. It's absolutely essential in this one to keep everything lean, nice and lined up and nice and neat. All right, so that's long division. Now, there's a shortcut that works sometimes. Roman numeral 3. Called synthetic division. It's a shortcut, but only if the denominator is linear. Denominator is linear, meaning not x squared or x cubed or x to the 4th. So if the denominator is x plus 5 or 2x minus 3 or 4x plus 7, then great, you can use synthetic. If it's x squared or x cubed, then synthetic doesn't work. Which does mean that you can use long division every time. So this is one of those places where, sort of like the people that use quadratic formula all the time, like it's sort of the harder method, but it works all the time. Same thing here. Long division works every time, so if you like it and it works for you, you can just roll with that. But synthetic division is quick. So let's try. We left off at number 3. 3x squared minus 6x plus 9 divided by x minus 5. Okay, so I'm guessing I don't know, maybe honors did this, maybe not. We'll start by writing down the coefficients, but just the coefficients. Coefficients of the dividend, if we really want to go back to elementary school and use the fancy words. Coefficients of the dividend. They go in sort of a box themselves, but leave it's a 2-line box, so there needs to be some space down there to work. Here's the way I think of it. If x minus 5 is a factor that works, like that's kind of what we're testing when we divide, to see if it divides in evenly, then we say it's a factor. If x minus 5 is a factor, then what would the root be? 5. So we're going to put a plus 5 right there. So it's that whole factor root switcheroo sign change thing. All right, here's the process. Sometimes people forget what to do first. Copy down the 3. Copy down the 3. Don't just move it down. Don't do anything with it. And then you're not doing any figuring out what divides into what. We're just going to multiply. 5 times 3 is 15.
Oh, I remember doing this.
Okay. Do you remember what you do next? I would say add. Let's add. Negative 6 plus 15 would be 9. Multiply again. 45, add again, 54. Okay, how do we make sense of those numbers? What do those mean? Good, you go 1 degree lower. If you're doing an x squared divided by an x, you're going to land with an x. So you're going to go 1 degree lower than what you started with. So this was an x squared, so now we're down to x and 9. Uh-oh, but now I'm out of stuff. What's the 54? That's the remainder. The remainder is 54. And so 3x plus 9, and either remainder 54 or plus 54 over x minus 5. And it kind of depends on the problem as to whether we want the remainder or the fraction. Five x cubed plus 2x squared minus 7 divided by x plus 2. So what are our coefficients that go in the box here?
5, 2, 0, and negative 7.
Very nice. Luke was not fooled. Again, with the missing, if there's a missing term, you've got to account for it. So be super careful. It's really easy to get rolling on these, and you think you got it down super quick, and you're just going to write down 5, 2, negative 7 and roll with that. So slow yourself down enough to recognize if you're missing something. What number goes on the outside? Negative 2. Again, if the factor is x plus 2, then the root is negative 2. Copy down the 5. See if you can take it from there. Multiply, add, multiply, add, multiply, add. So 5, negative 8, 16, negative 39. Again, 1 less power. Or you could start at the other end. Some people do that. They say, well, that's the remainder at the end. So 16 is the number. And then we start counting up. 8x and 5x squared. So you can kind of start at either end. The last number is the remainder. The first number is 1 power less than you started with. But either way, things should work out. By the way, if you left out the 0, then things would not work out, and maybe you would catch on that something went wrong. Like the remainder powers, like it wouldn't work out for you. All right, now we can start asking some questions using this stuff. If 4x cubed plus 2x squared minus 4x plus k, yep, that's a k, divided by x plus 2 equals 4x squared minus 6x plus 8 plus 3 over x plus 2. Find k. Give me a minute to copy that down. What in the world do we do? What do you think? What do you mean work backwards? Because we will work backwards in a minute, but before we work backwards, how would we normally work this problem? Forget the k, that was just a number. Yeah, let's synthetic divide and see what happens with this k. And we know what the answer is supposed to be, so maybe when we get toward the end, it'll make more sense. 4 to negative 4 and k seems a little bit weird.
Is K not like 1? You don't put
I don't know yet. Oh, it's 1k, but we don't know what k is.
Well, you don't put like a 1 instead of the K, like the coefficient of 1.
Yeah, but it's not, k isn't a coefficient, k is the number that we're looking for. Like I know what you're saying, the coefficient of k is 1, but that's not what we're looking for. We're looking for k. Negative 2 goes there. So 4, multiply, add, multiply, add, multiply. How do I add k and negative 16? It's kind of a trick question. It's k minus 16. Now we start matching things up with what our answer is supposed to be. 4 and 4. Okay, so far so good. Negative 6, negative 6. Yep, good there. Running out of fun colors to use. 8 and 8, that works. But then this last one, k minus 16 is supposed to be 3. Therefore, k is 19. So it's not that hard of a problem. It looks kind of weird, but you do the synthetic division, and then everything matches up except for that last little bit. Make them match up and solve for k. Okay, 2 more things to say. If r equals 0, then the divisor is a factor. That sounds kind of fancy, but if you think back to elementary school division, 12 divided by 4 is 3 remainder 0. You wouldn't even put the remainder 0 on there. You'd say 3, but when you first learned it, you'd say, oh, there's none left over. It goes into it evenly. And then later you learn that means that 4 is a factor of 12 because there's nothing left over. It's the same thing here. Here's how we use that in a problem. If x to the 4th plus 2x cubed minus 6x squared plus k, we're missing a term there, has a 0 at x equals negative 1, find k. Okay, well let's do our synthetic division. So 1, 2, negative 6, 0, and k. Oh, this is almost double tricky here. What number are we going to divide by? Negative 1, because that is the 0. Right? The factor would be x plus 1, but they already gave us the 0, so we'll use negative 1. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and then here we go with this add again. K plus negative 7 would be k minus 7. Okay, so if I want x plus 1 to be a factor, if I want negative 1 to be a 0, what should be true of the remainder? It's supposed to equal 0, so we take this last little bit and say k minus 7 has to equal 0, so k equals 7. Alright, racing against the bell. One more problem. This is kind of crazy, this last idea. The remainder, using synthetic division, gives the value of the function. That's maybe weird. Let's just work a problem. It's a lot easier than it sounds. If f of x equals 3x to the 4th minus x squared plus 2x minus 7. Find f of 2. Okay, so before the remainder business, if I ask you to find f of 2, what would you do? You'd plug in 2. Should be kind of annoying because you got 2 to the 4th and 2 squared and a lot of stuff going on. Well, it turns out that if we synthetic divide with 2, then whatever our remainder is f of 2. So this is a weird thing that synthetic division, the remainder of it, tells you the answer to the problem. And doing this is an easier way to evaluate f of 2. Copy down the 3. 3 times 2 is 6. A lot of multiply adds. Lots of places for silly mistakes in here, right? Because there's 5 multiplications and 5 additions. And so I'm trying to go fast, but not so fast that I make a mistake. So remainder is 41. That means that f of 2 equals 41. Which is kind of weird that works. So you could plug in 2 and do all the multiplying and fourthing and squaring and adding and subtracting and land at 41. Or you can sort of plug in 2 to synthetic division and you also get 41. It's a weird thing that works that way. All right. In the nick of time, we finished your assignments worksheet 5. Again, you'll have plenty of time to work on it because the next time I'll see you is next Thursday. So, plenty of time to work on it. Answers are posted. Again, you'll have an assignment Tuesday, Wednesday, but it should be a finishing class assignment. No new notes, no homework. So it should be a lighter, not a nothing 2 days, but a lighter 2 days.